All right, good morning. If you guys successfully sign up for my AP and total registration, I know some people have already done both of those. If you have that completed by Thursday, I will add bonus points onto your test. If you are not sure if you've completed both of those, please check your email for messages from Ms. Voland. It has the steps and the directions to make sure that you have done those two steps. Let me get attendance taken real quick, and then I will take any questions you guys have from the review. So if you want to go ahead and pull your reviews out, I will spend class time talking about whatever it is that you guys want to see or go over. What would you guys like to see? What would you guys like to see? Yes, sir. 14? Absolutely, number 14. 80 volunteers who currently use a certain brand of over-the-counter allergy medication have been recruited to participate in a trial of new allergy medication. I want to stop right there for just a second. Is this a random sample? No. We have volunteers, so it is not a random sample. If it's not a random sample, does that just mean it's no good? No. We can't generalize beyond just the people that are there. So these 80 people we can make conclusions about, but we can't generalize it out to any larger population. Good call. The volunteers are randomly assigned. Ooh, random assignment is going to let us do what? Establish cause and effect. The volunteers are randomly assigned to one of two groups. One group continues to take their current meds. The other group switches to the new experimental medication. Each is asked after 2 weeks if their allergy symptoms are worse, better, or about the same as they were at the start of the study. Which of the following describes a conclusion that can be drawn from this study? I'm going to draw our attention to this for just a moment because these multiple choice questions are notorious for slipping in a not sometimes. So be sure that you're reading carefully. We want to know which things we can conclude from this. We can determine whether the drug reduces symptoms more than the old drug for anyone who suffers with allergies. Why not?
Because there was no random sample, which means it can't be generalized.
Yes. No random sample. So we cannot generalize to anyone. We can determine whether the new drug reduces symptoms more than the old drug for the subjects in the study. That certainly seems feasible. I'm going to put a check mark because I think that is probably something we can conclude. I'm going to read through the rest of the options and make sure that that is truly the best one here. We can determine whether the allergy sufferer's symptoms improved more with the new drug than with the old drug, but we can't establish cause and effect. No. It says can't establish cause and effect. Why is that not true again? We can because we had random assignment. Can because random assignment. All right, so I know it's not C. I know it's not A. I'm leaning heavily towards B, but I'm going to finish reading my options. We cannot draw any conclusions, since all the volunteers were already taking the old drug when the experiment started. That doesn't seem very realistic. If that was the case, we'd never be able to find out if a new drug does better than an old drug. So no. We cannot draw any conclusions because there was no control group. Is there a control group? I would say in this case there is a control group. They're just going to keep doing what they were doing. They're still taking medicine, yes, but they were taking medicine before. And they're just going to stay doing what they're doing, and we're going to use that as our baseline for comparison. So yes, B is the correct answer here. It is the best choice of all 5 of these. What else do you guys want to talk about or look at? Yes, ma'am.
16.
Number 16. 16, which part?
D.
D, sure. Do you guys want to run through the entire problem? All right. Explain why this is an experiment and not an observational study. What is it that makes something an experiment versus not an experiment? We kind of saw this yesterday when we were doing the FRQs. There's a treatment. Treatments are being imposed on, not chosen by our subjects. They are being imposed on our subjects or our patients here. So it's an experiment because treatments are imposed on the subjects, and we want to go ahead and name what those treatments are so that we make sure to hit all those pieces. It is an experiment. Because treatments, what are the treatments here?
Taking vitamin E for 2 weeks versus taking a placebo.
Yes. So vitamin E versus placebo. Were imposed on the subjects or on the patients. We want to be careful, just like we saw yesterday, when we're talking about explanatory variable and response variable. What's the explanatory variable here? Heart patients are our subjects. The explanatory variable is going to be the thing that we think or that we're pretty sure is going to cause a response in our response variable. So what is it that we think is going to do that? No, you're fine, Tamia, go ahead.
Me?
Uh-huh.
The vitamin E.
Vitamin E.
Whether or not it prevents damage to the heart muscle.
That's going to be what we're hoping to see out of it. So vitamin E, is that the only treatment condition?
Placebo.
Placebo. We want to make sure to name both of them. So vitamin E and the placebo. You could say vitamin E and no vitamin E because the placebo looks, tastes, smells, feels just like the active ingredient treatment, but it has no actual active ingredient in it. So the idea with the placebo is that our subjects, our patients, shouldn't know which one they're getting. Why do you think that would be important, that we don't want them to know which group they're in?
They could act a certain way.
They could act a certain way. There's also extreme amounts of documented evidence for the power of hope. And people will even minutely change their behavior if they already think that the outcome is going to be positive. So in this group that's in the vitamin E group, they're like, I'm getting this other thing that's going to help my heart function better. That's awesome. I'm going to make sure that I'm watching the food that I'm eating. I'm going to try to follow the physical therapy regimen that they've given me. They might be more committed to the treatment plan than if they think, well, I'm not getting any extra help with this. So we want to try to control for that behavior by making sure that if we're going to say that vitamin E is causing this, I want to know that the medication by itself, regardless of someone's feelings, behaviors, opinions, anything else, that it's the vitamin E that's doing this cause and effect here. All right, so our explanatory variable is vitamin E and placebo. What is our response variable then? What do we expect to change because of getting either the vitamin E or the placebo?
Better heart function.
Yes. I would say, so we think if they get the vitamin E, it'll be better heart function. But I'm just going to put kind of like the range of heart function here, or some kind of measurement of heart function. I'm remembering what we saw yesterday on the FRQs. We want to be talking about all the possible outcomes. So, yeah, I would say heart function is fine, or the rate of heart function. I really don't know exactly how they're measuring this. It doesn't say. I would assume it would be with some kind of like EKG, but I don't know what would be good versus bad. Yes, ma'am.
This is like the amount of free radicals.
Oh, yeah. My apologies. You're right. It does say that there. I apologize. I'm still going to claim complete ignorance that I don't know how they measure that. But yeah, you're right. They're talking about well, here it talks about the heart function. Based on the language, I think they're making some suppositions here. I don't know that for sure because I don't know how the study was conducted exactly. But using words like apparently, I'm like, that sounds like it might be, granted, evidence-based, but an evidence-based reach or an evidence-based opinion here. What kind of design are they using here? So when we talked about experimental design, we talked about a completely randomized design approach. We talked about blocking. Do you guys remember when we talked about block design? Why do we use block designs?
To limit a possible confounding.
Yes. We know for a fact with certain medications that male and female bodies respond slightly differently. So if I think going into testing something that might be a confounding variable, I'm going to separate my subjects into blocks by gender. And then I'm going to conduct my experiment with the females, and I'm going to conduct my experiment with the males, and then I'll compare those results. But I'm trying to make sure that I'm reducing any variability. That's why we would choose a blocking method. All right, so there's completely randomized design. You just randomly split the people into two groups, and you talk about how you're going to do that, but you just number them and randomly put them into their groups. Blocking, you separate them out into these homogeneous groups by your blocks, and then you randomize. And then we had also talked about a matched pairs design. Do you remember what a matched pairs design is? In a matched pairs design, it's similar to blocking, but my blocks are going to be of size 2. So, for instance, if I wanted to know about seniors getting into their top choice college, if I did just a completely randomized design, I take the entire senior class, I take a random sample, and I split them into two groups. We're going to end up with people that have very different GPAs, very different future plans, very different ideas in each of these groups. That's going to increase my variability. If I instead match, I take my top 2 seniors and I match them together. And then I take the 3rd and 4th and I match them together. And then the 5th and 6th and I match them together. And I randomly assign them to groups from there. That is a matched pairs design. This also gets used to reduce variability. So those are kind of the 3 experimental designs we've talked about. Which one does this one seem the most like? Do they talk about matching? Do they talk about blocking? So if they don't talk about either of those, we're going to assume it is what? What was our third option? That'd be a sampling method, not an experimental design, but close. This is going to be a completely randomized experimental design. completely randomized experimental design. What would I point to as evidence for that? Just a very small little snippet in here. What could I point to from the article to support my choice of a completely randomized design?
14.
Yep, 14 randomly assigned patients. Each of the 14 patients was randomly assigned to one of the two treatment groups. Does each group receive a treatment? Yes. What are the two treatments again? The placebo and the vitamin E. Each one of those would be considered a treatment. Do we expect both of them to be effective? Would you expect both the placebo and the vitamin E to be effective? No. So just because we suspect that it's not an effective treatment doesn't mean that it doesn't count as a treatment. It is something being imposed on this group of individuals. Do we have a control group here? What would our control group be? The placebo group, yes. That would be what we're using as a baseline for comparison. So taking a pill with nothing in it, but taking a pill, these are the kind of results that we see. Taking a pill with vitamin E in it, we're going to compare to the other one. All right, now we're finally getting to the part that you asked about, part D. In the second sentence above is the phrase, the 14 patients who took vitamin E for 2 weeks before their operations had significantly better heart function after the procedure. Can the results of this study be generalized to the larger population? Can we generalize to the larger population? What is it that allows us to generalize? Random sample. Do we have a random sample? No. If I go back and read this, it tells me a study involving 28 bypass patients. If I'm thinking larger population, I'm probably not just thinking heart patients, I'm thinking people, Americans, Hoosiers. Can we take this and generalize it out? Like, should everybody just start going and taking vitamin E for better heart function? No. Could it be beneficial? Maybe. Not sure. We didn't test for that here. So we cannot generalize to our larger population. Because we don't have a random sample. My guess would be that this was probably all the people in that particular hospital that were receiving that particular treatment. I don't know that for a fact, but they didn't say anything about choosing a random sample from their patients. They just told me that they had these 28 patients. So they're probably volunteers. Can we talk about cause and effect? Yes, why? What allows me to make a cause and effect statement? Random assignment, yes. Yes. We can infer cause and effect because we had random assignment. So I know up in the little blurb of the article, it said that the people that got the vitamin E had significantly better heart function. What if it was determined as they were analyzing this that it wasn't statistically significant? What would that mean? If it was determined that it was not actually statistically significant? Does it mean that there was actually no difference between these two groups? John and Jen, what's in a name? Does caffeine increase pulse rate? Do you guys remember when we did those two activities? After we collected our initial data, I wrote everything down on the note cards. I wrote all of the collected information on note cards and then did what with that? Yeah. Passed it out to everybody and we shuffled them up and we dealt them out randomly. We were assuming that this difference that we observed was purely due to chance. And so we ran several simulations. Each person in this room ran a simulation. They said, okay, if it was due to chance, then it doesn't matter which pile it ends up in. It could have just as easily ended up in this pile versus that pile. We did this over and over and over, everybody in this room. So we had 23, because I participated also. And then we looked at how often the results that we found initially happened just by chance. Do you guys remember that? If they determined that the differences that they saw were not statistically significant, what that means is that by the luck of the draw, people that were already going to have better heart function ended up in our vitamin E group. And people that just by chance, just by luck of the draw, were going to have a harder time recovering and not have great heart function, ended up in our placebo group. So if it's not statistically significant, then any differences that were seen in the end were just due to chance and not due to the vitamin E. Any differences observed in heart function between the two groups was due to chance, or was likely due to chance, and not because of the vitamin E. Is it possible that they did this experiment, they found differences between the two groups, it wasn't statistically significant in this study, but the vitamin E really is effective? Is that something that could possibly happen? Yes. This is one of the reasons why it's so important to repeat experiments multiple times, not just through simulation, but actually going out and doing the experiment more than once. One of the things that you'll notice, studies that come out with very surprising results, they'll make splashy headlines. We've just discovered that if you wear one red blue shoe, you are less likely to get into car accidents. That would be something that catches people's attention. It's new, it's different, it's rare, it sounds exciting. If you have the same results or similar results when you run this experiment again and again and again, then we can start to say, yeah, I really do think that this is definitely cause and effect linked. If they repeat the study again and they don't get these surprising results, they're like, yeah, that was actually not that special. Does that mean that they did a horrible job on this one? No. But it does mean that it was actually due to chance and not actually a cause and effect. All right, what else would you guys like to talk about? Yes, sir. 15? Yeah. Absolutely. Bias is present in each of the following sample designs. In each case, identify the type of bias involved and state whether you think the sample proportion obtained is higher or lower than the true population proportion. A political pollster is seeking information on public attitudes towards funding of pornographic art by the National Endowment for the Arts. He asks a simple random sample of 2,000 U.S. adults, rather than support government censorship of artistic expression, are you in favor of continuing federal funding of artists whose work may be controversial? What do you guys think of that question? Kind of feels like guilt tripping. Does that question get to the heart of what he's trying to find out? No. Has he worded it in such a way to try to get a particular response? There are certainly people that feel that not having this grant option open to everyone is a form of censorship. But if you're trying to get the opinions of people and you word it this way, do they actually know what they're agreeing or disagreeing with? No. This is called response bias. If you want to look back at the different types of bias that we talked about, in your notes packet, this was the one that had like the mayor of Springville from The Simpsons on it. Some people will even refer to this as wording of the question bias. %85 of the people that he surveyed answered yes. Do you think 85% is the true population proportion? Yes, ma'am.
Well, also, could you also say that there's bias because he only surveys adults?
You could. I could argue either side of it. This is one of those kind of gray areas. But there are quite a few people that feel that since it would be adults that would be voting for the legislators that make the decisions about where funding goes, that narrowing it down to adults, because those would be the interested parties who can make decisions about this, would probably be fair. But yes, you could make an argument there. Absolutely. True population proportion, if you strip away all the fancy language, because we know what he's really asking about. Do you think the true population proportion is 85%? Do you think it's higher than 85%? More people would say, yes, we should fund this. Or do you think it's lower than 85%? Lower. So the true population proportion is likely lower than 85%. This is an overestimate. We saw this same kind of thing happen when we did the Beyonce activity, and I asked you guys to pick out 5 words quickly and then count the letters. We ended up with an extreme overestimate as far as average word length, if you look at the red poster over here. Part B, in 2003, AARP, which is the American Association of Retired People, conducted a survey of their members, people over age 50 who pay membership dues. You don't just automatically become a member of AARP when you turn 50. You actually have to pay your dues to be a member. They asked their members questions about proposed Medicare legislation. One of the questions was, even if this plan won't affect you personally, either way, do you think it should be passed so that people with low incomes or people with high drug costs can be helped? 75% of the respondents said yes. This has a form of bias in it. So when we're talking about the population, I want to know who would be affected by Medicare legislation? People over the age of 50. Did they pull their sample from everybody over the age of 50? No. No, they did not. So what kind of bias is this? Undercoverage, yes. Some people that this legislation is going to affect aren't being given the opportunity to respond to this survey. Who did they not talk to? Who did they not talk to that this could affect? People that are not AARP members. So I don't remember all of my ins and outs of government health care because there's Medicare and there's Medicaid. Medicare is for elderly, but it also gets used for people that are severely disabled and are expected to be severely disabled throughout their lives. Medicaid is for people who are just particularly low income. So if someone is born with a congenital birth defect or maybe they experience a birth trauma and they're going to need care throughout their lives, they would also qualify for Medicare. Do you think those people might want to have a voice in this legislation? Would AARP even consider those people as they're looking at this? No. So they only asked people that were their members, did not ask people who are not members, and did not ask younger people who this might affect. Do you think it's an overestimate or an underestimate? Yes, sir.
So I actually thought about the question a different way. Because the way it was worded, it's like, I was thinking it was response bias because of how the question was worded, where people with low incomes and high drug costs can be helped. So people obviously want help, so they would say yes. So that's how I was thinking about it.
I think you could probably make an argument for it that way. In this particular instance, I think the undercoverage is probably going to have more of an effect, but I think that that's absolutely something that could be affecting this as well. So we might have two different types of bias at play here as well. If we were to ask just the United States general public, Do you think 75% of the people would say yes? Or do you think it would be higher or lower? I would hope that it's higher. I've seen a lot of things over the last 4 or 5 years that make me scratch my head and wonder. But I would hope that legislation that is meant to help people that are having difficulties accessing health care, that would have higher support. So I'm going to guess that this is likely an underestimate. Of the true population proportion. We certainly want to point to reasons why we would say we believe that. Like if this was showing up on a free response question, you've got plenty of room to write. You could make an argument, depending on your particular evidence, you could probably make an argument either way. But you want to make sure to support it with evidence from what they've given you to work with. So far, so good? All right. Got about 7 minutes left. Depending on the question, I've got time for 1 or 2 more. Yes, ma'am. 13. Ooh, yes. Consumer advocacy organization wants to determine if using premium gasoline in the engines of foreign-made cars improves gas mileage. They randomly select 40 makes and models of foreign-made cars. Ooh. What is this going to allow me to do? Generalize. So, what group of cars will I be allowed to generalize to? All foreign-made cars? Available in the United States. They pulled their sample of 40 cars from the ones that are available in the United States. Now, depending on the random sample that they actually pull, if they find out that in their random sample of 40 cars, they don't get a single Mercedes, we probably can't generalize out to that then. So it would have to be foreign-made cars available in the U.S. that are very similar to the ones that we pulled in our study. We can generalize our results out to the population that we pulled from. Remember, we can only generalize to the population from where we got our sample. If I take a sample here at the high school, I can only generalize to people at this high school, not all Indiana high school students. What inference could you make about this study? So we have random selection, we have a random sample. Do we have random assignment? It does not say. If it does not say they're using random assignment, we have to assume that they did not. So can we make cause and effect statements? No. What can we talk about? If I can't talk about cause and effect, what can I talk about?
Association.
An association or a relationship. I don't know that one is causing the other, but I can talk about any relationships I see. So the inference that I could make is the association between gasoline type and gas mileage. With having not seen the study, they are assuming that Premium gasoline does what?
Improves gas mileage.
Improves the gas mileage. So regular gasoline would probably not have as good of gas mileage, or that's the relationship that they are identifying here. We can't make any cause and effect statements. All right, my entire key for this is up and posted. Make sure you go to modules and then go to today's date, the 11th. If you scroll all the way down to the bottom, here's a PDF copy of the review. The bottom one is the key. You guys have an independent review day tomorrow. If you have questions or you run into any problems, please send me messages in Canvas. I won't see any of you tomorrow. And then when I see you on Thursday, we will take your exam.